Hi everyone, have you ever built a tree house? You should probably try to send a message signal in the form of light as a secret code to your friends while you are playing. So this is what is happening inside an optical fiber. Today we are going to learn about optical fiber. Before getting to that, we have to know about what is Snell's law and what is refractive index of the medium. So without any further delay, let's get started. So we were talking about the refractive index of the medium. What is the refractive index of the medium? So the equation gives that n equal to c by b. So this is the ratio of speed of light in vacuum to the speed of light in medium. That means the velocity of light in vacuum to the velocity of light in medium. That is a refractive index of the particular medium. So what do you mean by Snell's law? Snell is a famous scientist who gave the relationship between the refractive index of two different medium with respect to the angle of incidence and angle of refraction. Let θ1 be the angle of incidence of the ray. The n1 is the refractive index of the medium 1 and n2 is the refractive index of the medium 2. And θ2 be the angle of refraction. So here the light is passes from one medium to another medium of refractive index n1 and n2 respectively. So let's see the relation. n1 into sine θ1 will be equal to the n2 into sine θ2. That means n1 divided by n2 will be equal to the ratio of sine of the angle of refraction to the sine of the angle of incidence. That means sine θ2 divided by sine θ1. So this is Snell's law, which gives the relationship between the refractive index of two medium with respect to the incident ray from one medium to the other medium. The property of bending effect of light is used in advantage of making the optical fiber. That means the light rays get bended when it travels from one medium to another medium. So before we are going to discuss about how the optical fibers are working, related to this principle, we going to study about the total internal reflection. What do you mean by total internal reflection? That is the principle behind the optical fiber communication. So now we are going to discuss about what is total internal reflection, which is the principle behind the optical fiber communication. So as I already told you, the bending effect of light will happen while it's traveling from one medium to another medium. So consider this figure. What will happen when light travels from denser medium to rarer medium? Look at this figure. So this is the denser medium and this is a rarer medium. So I drawn a incident ray here. So there will be an equal refracted ray from it escape from denser medium to rarer medium. That means light travel from denser medium to rarer medium, it will get bent slightly. As I increase the angle of incidence, the angle of refraction also will be increased. So as the angle of incidence is increases, the angle of refraction is also will get increases. As we can see in this picture, the refracted ray touches the medium of separation. That means if you continuously increasing the angle of incidence, the refracted ray go away from the normal and it touches the medium of separation. So at a particular angle of incident here in the picture, which is greater than the critical angle defined as at a particular angle of incident, the refracted ray touches at the medium of separation, which is called the critical angle. So in this figure we can say that the angle of incidence is greater than the critical angle. As I already told you, the critical angle is at a particular angle of incident, the refracted ray touches the medium of separation, which is called the critical angle, is represented by IC here. So if we increase the angle of incidence more than the critical angle, what will happen? The entire ray will reflected back into the medium and there is no refraction. This is what we call the total internal reflection. This is happened because of the construction of the optical fiber we are changing the refractive index of the two mediums. So basically the optical fiber has two parts like core and cladding. Core is made up of purely glass or silica substance, and cladding is made up of adding impurities to the glass and silica to reduce the refractive index of the cladding. So what happened when the light passes from the denser medium to rarer medium at an angle which is greater than the critical angle? What happened? The entire light will reflected back into the core and travel along the distances. So we can transmit the light ray by coding the light in the terms of electrical pulses, and we are sending that all over the world. That is the principle of optical fiber communication. So this is the illustration of the optical fiber structure. So what is happening inside the core is when the light ray passes from the core to clad, because of the refractive index of the core is higher than the cladding, what happened? The entire ray will be reflected back and its travel along to the tiny optical fiber tube. So in such a way that we made the optical fiber, so the claddings is made up of mixing the impurities of glass or silica, and the core is made up of pure glass or silica to increase the refractive indexes. So what we are doing here, coding the data in the form of light and allow them to pass into the core of the optical fiber. So total internal reflection is happen inside the core because of the refractive index of the core is higher than the cladding. Here, to reduce the refractive index of the cladding, we mix the pure silica or glass with impurities for that purpose. And so what happened? The total internal reflection happens inside the core, so the light can easily travel from one end to other end for a long distance.